Okay, I hope I did not confuse you too much with an email I sent yesterday about moving WebAssign 11. Okay, Eris brought up to me after class that it was asking about some stuff that we haven't talked about yet, so I moved it all the way to Friday as being due. Where is it? Not even on here anymore? Oh, there it is, WebAssign 11. Now, I left WebAssign 12 due today because that's roles in MVT. That should be over everything that you already know how to do. A lot of what's on WebAssign 11 you do know how to do, so some of you had already done some of it. Don't worry about it. I'm just going to talk about the last little bit of that today. Is everybody clear on when things are due now? WebAssign 12 today. Then we've got homework due Thursday, WebAssign Friday, and 2 FRQs on Friday. All right, is everybody clear on that? Okay. Before we get started on today talking about the first derivative test, this is a rather big ticket item that we're talking about today called the first derivative test. So I hope you can focus even though you just had lunch, but we really need to focus on it. Let's talk about what these things mean that we've got written on the board here, because we've talked about all of these over the last 2 lectures. We need to be sure we understand what are critical points. They are what? Okay, very good. That second part is what you've got to be sure and remember. Most of us remember first derivative being equal to 0. Okay? The undefined part is what most of us forget. So it's places where the derivative is either 0 or undefined. Those are called critical points, okay? And that goes directly into play with how do we find them. Critical points, and this is going to, by answering this third question, we'll kind of tie back to the first one. Why are critical points critical? What's important about critical points? What do they help us to give possibilities for? Yes. They are possible extreme values. They are not guaranteed to be extreme values, but they are possible extreme values. That's also why they're critical. They are the only possible extreme values other than endpoints. Endpoints. So we talked about that at length, that extreme values. What are extreme values? What do we mean by extreme values? They either occur at endpoints or critical points, but what makes them extreme values? What is it? Max and mins, okay? Max and mins. And if you'll go back and look, we talked about them being absolute max and mins, or global max and mins, or absolute extremes, or global extremes. Today we're going to define something called relative max and mins. All right? And I want to get to relative max and mins before we talk about review roles in MVT. Relative max and mins by asking you a question. Where's the cheapest place to buy gas? Racetrack. How much is it at racetrack?
About 209, I think.
209, I think it was 205 when I came by the QT this morning. 205, 209. Okay. Did y'all buy gas while you were traveling in Missouri?
I'm sure we did, but I guess
you didn't pay any attention. Did you pay any attention to prices in California? They were higher, okay. I traveled to Florida over the holidays, and I saw gas for $1.99. So racetrack's not the cheapest place. But when I ask where's the cheapest place to buy gas, what do you think I mean?
In the area.
The cheapest place in the area. Because although it's 6 cents less if I drive to Florida to buy the gas, I spent a whole lot of time and wasted effort going to save that 6 cents a gallon. So when we ask a question like that, where's the cheapest place to buy gas? We mean the cheapest in the area. So we're looking for the area. It's something in the area. So when we talk about relative max and mins, relative maxes and mins are the highest or lowest points in the area. Okay? In the area. Now that's a very vague term, but as we go through it today, you'll understand. So when you're looking for a relative max or relative min, you're looking for the highest or lowest point in the area. And that makes a lot more sense when we're talking real life scenarios because we aren't concerned about where the absolute cheapest place is to buy something. We want to know the cheapest place around here to buy something. Or we don't want to know the job that makes the most money. We want the job that makes the most money in the area that we want to live. You could probably make a lot of money if you were willing to go and live for 6 months out of the year at the South Pole and do whatever they do down there. But you probably don't want to go do that. So that's what we're talking about when we say relative max and relative mins. Okay? So as we just keep those terms in your head as we go forward. We then talked about Rolls and MVT. What was the gist of Rolls and MVT? You remember? You remember the premises for Rolls. What things had to be true before Rolls could apply to something?
Rolls is like F of A, equal like F of B.
Yep. The endpoints have to be equal. Continuous. And there's one other piece to it. That's the differentiable. What you said is the conclusion to it. So the function has to be continuous. The function has to be differentiable. The function ends have to equal one another. And if all three of those things are true, what do we know there has to be?
Some value C that makes
Some value C that makes f prime 0. There has to be one. If the endpoints are equal, then there has to be some value where the derivative equals 0. Provided it's continuous, provided it's differentiable, the endpoints are equal, that has to be true. Now, what in the given, out of those three things, what's different about Rolls and mean value? What's different in mean value?
F of A is not equal.
That's right. The only difference, still has to be continuous, still has to be differentiable, but the endpoints are not equal. And in that case, there has to be a C so that this is true. If I find the slope between the endpoints, if I find the slope between the endpoints, then there has to be a point where they're equal. Okay? All of these are just things we've talked about and discussed. If it's continuous, if it's differentiable, if the endpoints aren't the same, that has to be true. Okay? All of that's reviewed. Today, as we move into the first derivative test today and second derivative test on Thursday, I want to start off by looking at that graph. I've given you a function in function notation. I've given you the graph of that function. And I want to ask you a series of questions, hopefully that are relatively easy to figure out there. On what intervals is the function increasing? Okay, so talk about it with your partners there for a minute. Try to answer those 4 questions and come up with solutions, and then we'll come back and we'll decipher your answers and maybe learn something here. And the graph doesn't stop where you see it. It just keeps going in each direction. So I just drew those arrows up there so you can see that it keeps going in that direction there. So where's the function increasing? Where's the function decreasing? Whoops, spelling error. E-A-S-I-N-G. And the coordinates of relative max and relative min. So we'll talk about those. So on what interval is this function increasing? Anybody got an area, an interval? All right. So we would write it this way: negative infinity to negative 2 with parentheses if you're using interval notation. So it's the function's always increasing there. Anywhere else that it's increasing? Zero to infinity. So it's increasing on those two intervals. Well, is there any place that it's decreasing then? Negative 2 to 0, okay? And we didn't define what we mean by this, but increasing means the function's doing what? Going up. It's getting bigger. Now, I want to notice, because we're going to make your head hurt with questions that are going to be asked over the next 5 or 6 months. That doesn't mean the function's positive, does it, to be increasing? The function value is negative in all of these areas, but it's increasing. The function's increasing. The function's negative here and it's positive, but it's increasing overall. So increasing doesn't mean positive necessarily. Decreasing doesn't mean negative necessarily. Okay. Now, before we answer this question, tell me something special about these 2 points that I just circled. Tell me something. Derivative is 0 at both of those places. F prime is 0. So these are called critical points. Okay? Critical points at these 2 circles right here. Do you see a relationship with critical points and increasing and decreasing? That's right. In order to change directions, in order to change from increasing to decreasing, the function has to have a critical point. Okay? And going back, critical points are where the derivative is 0 or the derivative is undefined. Well, now, based on this, what would you say? Does this function have an absolute max? No. Does it have an absolute min? Because it keeps going in both directions. But does it have a relative max? Where would you say the relative max occurs?
What would that be on negative 2,
Right here. It occurs at negative 2, 0. This point right up here is a relative max. It's not the highest point anywhere, but do you agree it's the highest point in the area? Okay. What does it have a relative min, you think, then? And 0, negative 12. Okay? So when we say relative max and relative min, this is what you expect to see graphically, that it's got a high point somewhere around highest in the area. It may not be the highest overall, but it's the highest in the area. The same with the low point. It's the lowest in the area. But finding increasing and decreasing and finding relative max and relative min is relatively easy if you've got a picture, isn't it? I liked the pun there, didn't you? I like that you laughed at it. That gets you a brownie point sometimes. What if we don't have a picture? What if we don't have a picture? How are we going to find those things? Okay?
you might find the critical point.
Yeah, it makes sense that we need to find the critical points, doesn't it? Because we found that at these 2 places, at the critical points, things changed, okay? So we're going to kind of be going back and forth between these 2. So let's start off by finding our critical points, okay? So the first thing we're going to do is find the derivative, negative 6x squared plus 6, and set it equal to 0. I told you, if you don't know what to do, find the derivative and set it equal to 0. It's probably going to be right. Now, can we solve that out? How many answers do we expect to get there? 2. So let's solve that out. Negative 6, I'm going to factor that out and get x squared minus 1 equals 0. So x equals plus and minus 1. I got 2 answers out of it. So I've got 2 critical points. Would you buy that? All right. So now, that kind of relates to these points here. Well, I don't know if they're maxes or mins or whatever, but so how can we figure out whether the function's increasing or decreasing before that? Plug in numbers, okay. How are those numbers going to tell us? What are those numbers going to tell us? All right, whether the function value is positive or negative. Yes, it is. But just we found here, we would have a negative function value, but the function itself would actually be increasing, wouldn't it? So now we could do what Jared said. We could plug a couple of numbers in here. Like if we found this at f at -4 and f at -3, and oh, it looks like it's getting bigger. Sounds like we'd probably have a good case for it being increasing. But is there something different that we could do? Can you do all of these points from right there all the way down here? Do all of these points have something in common that would let you know that the function is increasing? Very good. The slope's approaching 0, but the slope is also approaching 0 for all of these points if we go back that way. But that you're on the right track there. What about the slope over here? What can you tell me about the slope over here? The slope's always positive, isn't it? If the slope's positive, see if this makes sense. If the slope is positive, what does that tell you about the function? It's increasing. All right? Now, hold that thought for a minute. Jump over here to position, velocity, and acceleration. If I've got velocity, what does a positive velocity tell me about my position? My position is increasing. I'm getting further away from where I started, right? What if I've got a negative velocity? What does that tell me about my position? I'm getting closer to where I was. So kind of keep those two things in line there. So if we can figure out if the velocity, if the first derivative is positive or negative, suddenly we know whether it's increasing or decreasing. Because all of these points in here, the slope is negative, right? Would you agree? What about all of these points over here? Slope on that's always positive. So what we need to do is figure out, is the slope positive or negative around these? And we're going to do that by doing a sine line. Remember that thing we did yesterday? So let's see if we can remember how to work out a sine line here, okay? We're going to start off, we'll draw a sine line, just draw a number line. We need to put our critical points on there, okay? So we've got a critical point at -1. We've got a critical point at +1. Get in the habit of labeling your sine line. This is f prime of x. Because problems you do later, we might need to do a sine line for f and for f prime and for f double prime. So it could get all sticky there. So be sure and get in the habit of labeling it. Now, remember, we talked about this yesterday. We know that the derivative is 0 at these two places, at -1 and +1. And we know that everywhere between here, the derivative is either positive or negative. It can't be positive sometime and negative sometime. Why is it either positive or -1? Why can't it change in there between these two? That's right. If it went from positive to negative, it'd have to be 0 in there somewhere. So now, what I would do is I'm going to write out all of these factors. This is what gets students confused. What are factors? What does it mean to be a factor of something? A root? How do factors make up the original problem? Factors are things being what? Multiplied together. So they are things that are being multiplied. You can't have these two things are not two factors of this. It's not negative 6x squared as a factor and 6 as a factor. They're add-ins of one another. These are factors when things are being multiplied. So I'm going to come down here and below my sign line, I'm going to write out my factors, negative 6 and x squared minus 1. All right? Anybody remember what we do from there? Plug in numbers. Anything but these numbers. We need one number out here to the left of negative 1. I'd use the easy one, negative 2. When I plug negative 2 into this first factor right here, is the answer positive or negative? That's all I care about. Is the answer positive or negative? Negative. Okay? Because there's no x to plug in there. No matter what x is, this first factor is negative 6. What happens when I plug negative 2 into this thing? I get a positive number. The number itself doesn't matter. The fact that it's positive is all that I'm concerned about. So talk to me about the derivative at that at negative 2. Is it positive or negative? It's negative. What does that tell you about the function? Is it increasing or decreasing? Decreasing. The function's decreasing. Can everybody picture that in your mind now? We know the derivative is negative, so the function's going down, so the derivative is so the function is decreasing. Remember, I told you that the word "it's" not a good word to say in here. It isn't decreasing because I don't know what it is. The function is decreasing. The derivative is negative, so be specific about what you say there. Okay? We need to pick a point between negative 1 and positive 1. What's the easy one? 0. When I put 0 into this first factor, it is positive or negative? Negative. Because there's no 0 to put in there. It's just a negative 6 always. What happens when I put 0 into this bottom factor? I get negative. And a negative number times a negative number means it's a positive number. Okay? So suddenly we know that what's the function doing from negative 1 to positive 1? Is the function increasing or decreasing? It's increasing because it's positive. All right? Let's go over here to bigger than 1. When I put 2 in here for negative in the factor that's negative 6, there's no place to put the 2 in, so it's just automatically negative. When I put 2 into the bottom thing, what do you get? Positive, and a positive times a negative makes it negative. That tells me the function is decreasing. Okay? Now, some of you may have said back up here, wait a minute, can't you factor x squared minus 1? Yeah, you can. You could have factored it to x plus 1, x minus 1, couldn't you? Would that change your answer? No, it wouldn't. It would change what you did down here. I could have just as easily written this out if I'd wanted to. Instead of that, I could have said it's negative 6, it's x minus 1, it's x plus 1, and had 3 factors in there. You'd wind up with the same answers. It's a little bit more work, but you'd have a negative number times a negative number times a negative number to make it negative or something like that. So you just have to, it depends on how you want to break it out. So Matthew may say, hey, that's all I need to factor this puppy. I'll use it like that. Marlon may say, no, I need to factor it all 3 times like that. Jared may look at it and say, I don't need to factor it at all, folks. I'm just going to use that as my, it doesn't matter as long as you use something to figure out because you're concerned about where's the function positive, where's the function increasing and decreasing. Now, so what interval would you say this function is increasing on? From where to where? Negative 1 to 1. That's how you'd want to write it. Where's the function decreasing at? Negative who to negative 1? Yes, negative infinity to negative 1 and 1 to infinity, okay? Now, so can you figure out the maxes and mins from that? Can you figure out relative max and relative min from what you got there? Is this right here enough information for you to be able to say, yeah, I think that's a relative max or relative min? How would you go about it? Well, let's see. This says that the function's doing what? It's going down, right? So we don't know what the function looks like. It might, but we do know it's going down. What does this positive sign here tell us? What's the function doing there? It's going up. So we know it's going down at those places. It's going up at those places. So what do you think about -1? If the function's going to go down and then go up, what about -1? This is a min. This is going to be a minimum right here because the function's going to go from down to 0 to up. What about this point here? The function's going up. Then it's going to be 0, then the function's going down. So what about this point over here? It is a max. Isn't that cool that you can figure that out without having to draw something? So you've got a pretty good idea that this function, based on this, does this function have a minimum? Does it have a relative min anywhere else? Why not? Those are only critical points. That's the only relative min. That's the only relative max. So tell me about what you think the function value is out here at -10 million. What kind of number would you describe it as? Really big, really small, close to 0? What do you think? Because all the way out here at -10 million, we don't know where the function is, but what do we know? It's going to be, as I get closer that way, what's the function doing? It's going down, it's going down, it's going down, it's going down. So the function, in order for it to keep going down all this time, what's got to be true of it? It's got to be really tall up here. So suddenly, we got a pretty good idea that this function's way up here somewhere to begin with, and it's coming down. And when it gets to -1, what happens? It turns around and it goes up. And what happens when it gets to 1? It turns around and goes down. So you've got a pretty good idea of what the function looks like already. Now, does it look like that? I don't know. It might do something like this. It might come way down and come just up a little bit and do something funny like that. It might come way down here and go way up there. I don't know, but that's the general shape of it. It's going up over there, it's going down over here, and it's got to do that loop-de-loop in the middle. You got a pretty good idea just from a little bit of play in there. Congratulations. That's called the first derivative test, what we just did. And this is what the first derivative test looks like in words, okay? But you just did the first derivative test. What did that say? Excuse me, oh, ridiculous. Okay, what can we figure out? If the derivative is positive, then the function is increasing. It's important to get the words right here. If the derivative is positive, the function's increasing. If the derivative is negative, the function is decreasing. Okay? It is not a good word to put anywhere there. Derivative is positive means the function's increasing. Derivative is negative means function's decreasing. That's something to memorize. You got to know that. The rest of your math career, you got to know those things there. If the derivative is 0, then it's constant. What would it look like if the derivative is 0? What would a function look like that had a derivative of 0 from A to B? Straight line? Well, all lines are straight. Yeah, it's a horizontal line. It's going to be a horizontal line from A to B, okay? That's the only things a function can do. It can go up, it can go down, or it can be horizontal. So that's all that can be going on there, okay? So those are the three things that can happen there. How do you do it? Tell me what we did. We found the critical points. We did a sign line. Those are the two things you need to know. If you can do those two things, you can figure this out. What else do we learn from this? if the derivative goes from negative to positive, talk to me about this point where it changed that. It went from negative to positive. Is this a max or a min? Min. If the derivative goes from positive to negative, that point is a max. And it's okay to make these movements if you need to for a while to figure out whether it's a min or max. But that's critical for everything that we're going to be doing the rest of the way, people. Everything from now until December, you've got to be able to do what we're doing right now. Find the derivative, set it equal to 0, create a sign line, determine maxes and mins. All right. Find the intervals where this is increasing and decreasing. Find all relative max and min. Somebody tell me what we're going to do here. What's the first thing we're going to do? Derivative equals 0. What's the second thing we're going to do? Sign line, okay? Get started on that sing line. Get started on that, and I'll come around and help you, or we'll put it up here on the board or something here in a moment, okay? Go. You're capable of doing this. All right, Mary, what did you get for the derivative? 3x squared minus 8x minus 5. Okay, that's good. So now when you set that equal to 0, what do you do besides cry, people? How do you do that? Grouping. For those of us that remember how to group, we're going to group those, and we're going to get an answer rather quickly. Those of us that are saying, I don't remember how to group, what on earth do? You got two other options. Quadratic formula. That's what I would jump to immediately. Quadratic formula is your best friend for the rest of your math life here. So I would jump into that if you don't remember. You could do the box method. I don't know, y'all remember the box method from Ms. Gilbert, some of you? Okay, we're not even going to talk about the box method. I would either remember how to group this thing, or I would go through and do the quadratic formula. Remember the quadratic formula. If you don't remember it, it's in a document at the top of Moodle, and you can plug into that. Those of us that do remember it, we just sing the song and we're happy with it. 8 plus or minus the square root of 64 minus 4 times 3 times negative 5 all over 2 times 3. 4 times 5 is 20 and 3 is 60, so we've got 8 plus or minus 2 over 6, which gives me 8 plus 2 is 10 over 6, which is 5/3. And 8 minus 2 is 6 over 6, which is 1. Did I miss something?
That's a negative 5.
Oh, bummer. That stinks. 4 and 5 is 20, 60, square root of 124. Oh, my goodness. So there really is a lot of crying involved in that, isn't it? Okay? Because it doesn't group, does it? Did yours group? Wow. Minus 3 and a positive 5. See, yeah, that's what I wanted to get too, but they won't let me. Minus 4 times 8 times. Negative 3 and positive 5. I know. No, negative 3 and negative 5. Yeah. Yeah. And then I factor an x out of 3x out of that, and I get an x minus 1. And I factor a negative 5 out of that, but I get an x plus 1. So I'm afraid it's that ugly thing down there, 8 plus or minus the square root of 24 over 6, 124 over 6. And that will probably reduce, but I don't really care to reduce it. So that's what we've got. Ugly. Sorry, but that's what we've got here. Sign line. We draw a sign line. We label our sign line, F prime. Notice I really don't care that you have marked a 0 point and measured these things off or anything like that, okay? All right? What are we going to use as our factors here? Well, you could say x plus, you could say x minus the positive of these and x minus the negative one of these. That's going to be painful, but you could do that. Or you could just use this that we had right here, couldn't you? Which do y'all want to do? The two factors of it, or you want to do just the derivative the way it was written there? Just the derivative, okay? So we've got 3x squared minus 8x minus 5, okay? What number is less than that? Anybody tell me? Would you agree negative 10 million is less than it? I mean, it's definitely less than it. So negative 10 million squared is a really big number. Let's just do 1,000. Negative 1,000 squared is 1,000,000. That's 3 million minus 80,000 minus 5. What kind of number do you think that is? $3 million minus $80,000 minus $5. You still got money? Still got a lot of money. So that's positive over there. So talk to me. What's the function doing up there? Tell me about the function. It's increasing. Very good. What's a number between these that we can put in? 0. 0, 0, negative 5. It's negative. So what can you tell me about this point right here? It's positive. It's decreasing. You're right. The function's decreasing. Function positive. Function's negative. Function's increasing. Function decreasing. This is a max. Okay? This is a max. All right? A number bigger than this is 1,000. 1,000 squared. I still got $3 million minus 80,000 minus 5. I think I still got money there. So what is this point here? Min. Okay? The mathematics of this is not hard. The difficulty is listening and answering the question that's asked. Okay? Because look at the types of questions I can ask here. I could ask, where's the function increasing and decreasing? Where's the max? Where's the min? Where's the derivative positive? Where's the derivative negative? All those questions, all of that's information you've got to be able to do. So we answered the max and min question. Let's write down some questions I can. Where is the function increasing? Where's the function increasing? How would you answer that point? Okay? Show you a trick that could be beneficial for you on the exam. Say A equals that. Pick any letter. B equals that. So where's the function increasing? It's increasing. Negative infinity to A. A lot easier to write, isn't it? Is it increasing anywhere else? B to infinity. All right? Where is the function decreasing? A to B. Notice we didn't put square brackets, did we? Why don't we put square brackets? Exactly. It's not increasing or decreasing at 0. For that moment in time, it's just there. It's just at 0. Okay? Where does a relative max occur? Where was a relative max at? A. Okay? Now, we're not going to answer this question, but I want you to understand the difference. What is the max? A is not the answer for that. What's the answer for that? How would you find the answer for that? What is the max? That's right. This, you've got to plug A back into the function and get a number out of it, okay? You have to plug it back into the function to figure that out. F of A is not the answer. I mean, writing that down is not the answer. Okay? It is in this case because I'm lazy. I'm not going to figure out that stupid number in there. But F of A is not the answer to write down on your paper what the actual value would be. I could ask, where does the min occur? You'd say B. Just see all these kinds of questions that can be asked. You've got to be able to put all of this stuff in your head and figure it all out. Questions, comments, observations so far? All right? Could this whole thing be done on your calculator? Let's pull out our calculating devices. Now understand, you must be able to do this by hand like we've just done with the examples. And we will probably go back and do another example here in a moment. But it's also important to know how to do these things on your calculator. So let's put on our calculator. Where do you think we begin on our calculator? Y equals. We're going to plug in our function there, okay? X raised to the third minus X raised to the second. Okay? So we put in our function. Now, if we graph this thing, the difficulty is getting a window that you can understand anything out of. Does this give you enough information to maybe figure anything out, you think? All right, so what do you think we ought to do? We need to kind of zoom in, don't we? All right, so you can either zoom to and see if that will zoom in for you a little bit. And look at that. That worked pretty good, didn't it? Looks like some things are happening right around in this area right here, okay? So, what we need to do is figure out the max and the min. Okay, but remember, we're looking for relative max and relative min. So on my calculator, I'm going to go second, calculate, min, 3. Have we used this before? All right, the second, calculate min. Now, it's going to ask you for a left bound, a right bound, and a guess. Okay? The left bound and right bound is determining your boundaries for your area. So we want a minimum right around here. Would you agree? Right around this area here. So we want our left bound to be somewhere around there. There's no exact number for it. I just press my arrow and move till, I want the minimum between there and somewhere over here. So there's my left bound. I'm going to press enter. Then it asks me, where's the right bound? So I'm going to move this over until I'm confident that I'm to the right of it, okay? Then I'm going to press enter. Now look on your screen. Do you see your two triangles? It says we're going to find the minimum between these two triangles. If you want to guess right now, you could move somewhere and guess. I don't want to guess. I'm just going to press enter. And that tells me there's my minimum at 0.666666729, and there's the minimum value. Okay? What do you think this is as a fraction, the 0.666666729? 2/3. That ending 29 out there should not mess with your mind and say, well, that's not what it would be if I tried to figure it out. The calculator is just having to round stuff off for you. So it's not going to give you exact. I'm confident that that means the minimum occurs at 2/3. Okay? Now we're going to do the same thing to find the max. So we'll do second, calculate, but instead of number 3, we'll go down to number 4 where it says max. Now the left bound for that needs to be way back over here, a negative x value somewhere. So we're going to move over here. I'm obviously to the left. The max looks like it occurs around 0. Then I'm going to move to where I'm obviously to the right of it. And again, I've got my triangles. Okay? I press enter, and it figures out. It says my max is negative 5.768 e negative 7. What on earth is e negative 7?
Like how many? Basically 0.
It's basically 0. This is saying it's negative 5.76 times 10 to the negative 7. It means it's got 6 zeros in front of that 5. It's a decimal, 6 zeros and 5. So this is saying it's essentially x equals 0. Where's the function increasing? From where to where? Okay, the function's increasing from negative infinity to 0. You can tell that by this here. Right, from 2/3 to infinity. Because what does the function do? The function goes up, the function goes down, the function goes back up. So it's increasing here, it's decreasing between 0 and 2/3. Questions, comments, observations? Am I just boring you to death at this point in time? All right, we just talked about that. If the derivative goes from negative to positive, the derivative goes from negative to positive, it's a minimum. If the derivative goes from positive to negative, it's a maximum. What if the derivative goes from positive to positive? The derivative is going up, then it becomes 0, then it goes up. Is this point a max or a min? Positive, 0, positive. Is it the highest point in the area? No, it's not. Is it the lowest point in the area? It's neither one. So if there's not a sign change, going back to velocity, what if I'm walking, I stop, and I pick up and walk the same way? Did I turn around? No, it's not a max or a min. Okay? So there has to be a sign change to be a max or min. If it goes from positive to negative, it's a max. Negative to positive, a min. If there's no sign change, it doesn't. It's neither a max nor a min. Do we need to work through another one, or are y'all comfortable? Okay. All right. Now, you've got a little bit of time to work here if you so desire, and we'll see how you feel tomorrow